All right, Charles from GMAT Ninja is still here. Hour number 17 of our 24-hour nonstop crash course GMAT marathon to benefit Ukrainian refugee charities. If you're watching this video down the road, you're just here to learn some stuff about whatever we're talking about here. This is going to be statistics and minimum maximum problems. And you like what we're doing, and this is something you'd be willing to pay for. You're seeing value in it. If this was part of a course you would have paid. We're going to jump in with a quiz, give you 5 questions, 10 minutes, Google form. Please punch your stuff in there. The crowd is growing again, which makes me really, really happy. Would love to see all of you guys putting your answers in there. Again, if you run out of time, just punch something and just make a guess. That tells me we can give you enough time. So Abhijit back there is being pretty precise about giving you 2 minutes per question. So please, please, please use the form. Better the data is, the better I can tailor the lesson to help you guys out. Okay, we're good. We got it. Okay, fantastic. Thank you so much to everybody submitting your answers. If you're still working on it, feel free to guess, punch them in. If I know that you didn't finish it in the 2 minutes, that's still really, really great information. Again, thing we're experimenting with today, I'm getting this quiz in so I can see the data and then kind of respond to it. Usually I tend to react to the live chat. And what I'm learning a lot about today is that the live chat, the people that actually kind of punch in their answers there, the ones that are happy to share them, usually doing really well. And what I'm finding is what I hear in the chat isn't matching the data, which I find absolutely fascinating. Not shocking, I suppose, but really, really interesting. So you guys are getting crushed by some of these. This is actually looks like one of the tougher quizzes. First question, pretty straightforward. But even then, I'm getting about 20, 22, 23% wrong on it, which I think is pretty interesting. And getting complaints on some of these. So this is fantastic. Means you got a chance to learn. If this is too easy for you, it means we're going to be wasting your time. Okay, so what am I going to be chasing in this hour? So statistics, standard deviation, min-max problems. Again, we talk about statistics on the GMAT. I mean, you can define that in different ways. Different test prep people will do so. They'll define it in different ways. Is probability and combinatorics part of statistics? In a technical sense, I suppose. Why not? I tend to kind of separate that out because I don't know, kind of operates in a different part of your brain. When I think of statistics, I'm thinking about mean, median. That's where a lot of those kind of min-max problems come from. There's a whole family of them where it's like, oh, the median is this, the mean is that. What's the largest possible value of one of the integers? Some of those questions we already got in a little quiz. Standard deviation is the other big one. So I'm cherry picking a little bit here. Weighted averages is another one. So I'm cherry picking a little bit. We're going to talk about some of the basic concepts here in these first 5. Again, I'm seeing a little more struggles than I expected, so we'll go over some of the foundations quickly as best we can. We only have an hour. Then I'm going to get into so some of the min-max kind of stuff where it's like, hey, you got to maximize one number means minimizing another, getting into some of that logic, try to get you nice and versatile with it. Then we're going to get a little bit of mixtures and weighted averages, show you a quick little shortcut for it if you don't already know it. And then we're going to spend some time on standard deviation. And if we have time, I really want to kind of get into there's some basics that I know some of you guys are missing. That's great. We'll touch on that really, really quickly. But then we'll also kind of get into some more conceptual stuff. And as you think about standard deviation, it gets layered into a question that's a little bit more kind of abstract, conceptual. I think I've got a couple from Buñuel in the deck. Time permitting, we'll get to those and kind of get into the sort of, I don't know, more abstract kind of thought you need to get into for the really, really tough standard deviation problems. All right, first question. Let's see if those numbers have shifted at all. All right, we're about 1/4 of the group is missing this. Not sure if that's carelessness or something else. So question basically here is, where's the median? Which of these groups is it in? And I'm guessing, I can check the numbers on this. What a lot of people do is they look at a table like this and go, well, the median must be in that middle group, and that's the end of the story. So your median must be somewhere between 40 and 49, which would be answer choice E. That is not the correct answer. And that is the answer chosen by almost nobody. You guys were making a different mistake, which I found really, really interesting. Okay. So when we're talking about median, you're looking for the middle number. Easiest way to handle it here. They did the math for you. They told you it was 161. Shouldn't be too hard to kind of go, well, all right, I'm looking for the 81st number here. Doesn't matter whether I count from the bottom or count from the top. It's going to be a lot easier to count from here. So 70, if I add these two up together, I get 87. So my median's got to be somewhere in there in that 20 to 29 range. So answer here is going to be A. Interesting. I'm a little surprised by the errors here because a lot of people are picking anything but E, and I'm not quite sure why. But this is more of just a paying attention kind of question. That's really it. All right. Number 2 gets a little more fun. Put that question back up here. A certain list contains the numbers. Oops. There we go. Yeah, I got almost half you missing this one too. So that's great. Certain list contains the numbers 2, 11, 3, X, 8, and Y, which the following could be the median of the set. This is where we kind of get into, it's not quite a min-max problem exactly. But you might even argue that the most common variant of statistics problems, thinking about it really broadly, as sort of, problems that involve the words mean or median or standard deviation or something like that. It's kind of these logic-y little guys where you kind of have to think through, hey, what's possible? What's the highest? What's the lowest? All right, great. So I'm just going to lay these out in order as much as I know about the order here. So I've got 2, 3, 8, and 11. X and Y, I don't know where they are. They could be anywhere. And I'm just going to kind of stick some arrows up there just to remind myself they could be anywhere. So it could be median of the set. 2.5, would that be possible? Sure, easy enough, right? If I just take the X and Y and put them over here, we don't know that these are positive integers. We don't know that they're different. We don't know anything. No restrictions at all. So no reason why your X and Y couldn't be here, which makes 2.5 your median, average of these two. So that's possible. Statement 2, 5.5, very obviously possible. That's going to be the average of 3 and 8. So we could have, let's say, X here and Y here, for example. That's very possible. Last one, could 8 be your median? Well, I think for 8 to be median, I'm going to need a couple 8s in there. So what if we got X and Y kind of right smack in the middle? And let's say, for example, that X is 8 and Y is 10. Nothing's stopping us, right? So could have any of these three. Answer's D. And again, a lot of struggles on that one, which I find pretty interesting. Next question. Very mechanical question. This is one of those kind of fairly rare questions where they're really just testing your knowledge here. And you don't see that all that often. It's like basically if you've taken stats class, you're going to get this right. If you haven't taken stats class and don't remember it, or you've taken it and it's gone, you might struggle a little bit. But that's really it. Have you seen this stuff before? I'm going to go through it super quickly. If you want more detail on this, we're going to have kind of a more foundations level version of this up on the GMAT Ninja YouTube channel coming up in the next few weeks here. The quick and dirty version, normal distribution. Actually doesn't even say that here, but that's kind of what they're referring to, even though it doesn't use the word normal. So a certain characteristic in a large population has a distribution that is symmetric about the mean M. So again, if you're taking your stats class, you can kind of imagine a nice bell curve here. Mean is M, it's symmetrical, great. 68% of the distribution lies within one standard deviation of the mean. Now, conveniently, this is exactly what happens in a standard normal distribution. So this is one standard deviation below the mean, one standard deviation above. Question is, so one standard deviation is D, so I get plus 1D here. And what the question's asking us for is if 68% of the distribution lies within one standard deviation, what percent is less than M plus D? So there's M, there's your plus D. So right here is M plus D. And again, we know this thing is symmetrical. How much do you really need to understand about statistics to get this? I'm not sure you really need a ton here. all we need to be able to recognize is, can I kind of draw this out? I know it's symmetrical. So if this is 50% over here, I mean, a lot of ways you can do this. You can kind of say, well, 68% here, that means kind of in these two tails, probably the easiest way to do it. And my drawing gets worse and worse as I get past hour number 10, hour number 17 here. I draw like a drunk 4-year-old. So that remaining 32% is going to be split here and here. So 32 divided by 2, this is 16% in that tail, 16% in this tail. We want to know what percentage of the distribution is less than m plus d. So we're looking at this thing, that's 16%, and then we've got this whole 68%. Add those two up, we're in business. My math is fading, 84%. So we should get answer choice D there. And again, how do we do? Yeah, about a little less than 60% correct there. Don't stress too much about this stuff. This isn't super, super common on the GMAT. I mean, this is maybe, I mean, at best, kind of 1% of questions that requires you to kind of think through a normal distribution at all. And this one in particular, you don't need to know a lot about it. It doesn't even use the term normal. It's just being able to think about what we mean by symmetrical and give yourself some sort of visual for it. That's really all it requires. So next question. And was this the one that folks were complaining about? Yeah, we got about 45% correct on this one. So that's cool. Ooh, I'm not even sure that we got that. That's pretty interesting. So a certain list consists of 400 numbers, 400 different numbers. And we want to know, is the average, so is the mean greater than the median? And this is where we get into this nice conceptual messiness that's a lot of fun. Of the numbers in the list, 280 are less than the mean. Okay, so what does that tell you? Has to be true. The median is going to be between the 200th and the 201st, right? So what we're saying here is, if, I don't know, let's picture, let's maybe put them on a number line and imagine that this is 400 numbers and that they're evenly spaced here. What do we know? The mean is here. I'll exaggerate a little bit and put it towards the high end. Sorry, that's the mean. 280 numbers here, 120 numbers here. Your median's got to be smack in the middle by definition. So here we definitely know that that mean is bigger than the median. So A is sufficient. Statement 2. Of the numbers in the list, 30% are greater than or equal to the average. Well, this is exactly the same piece of information, right? So 400 numbers, we know that 30% are greater than the mean. That's going to be 120 here that are bigger than the mean. That means 280 or less than that. What do you know about the median? The median is always going to be between 200 and 201 in this case. Doesn't matter what it is. So same exact information as statement 1. D is our answer for number 4. And again, I'm not sure. This is absolutely fascinating to me, and it's wonderful to see, because it means that I'm striking a nerve with this content, which is great. Yeah, we had a bloodbath here, so that was 45% correct. And again, I'm not sure if this is, I'm getting some comments in here. I need to review stats. In a way, yeah, but there's nothing technical here. It's just making sure that you recognize the definitions of mean and median. And you don't even really need to be able to calculate anything here. It's just being able to think through the idea that, well, yeah, the median's right around number 200, 201. It's between the two or the average of the two. That's it. And as long as you can kind of follow the logic of the idea of a distribution, you're in good shape here. Maybe just need a little more time. I'm not sure, but this is great. I know we're striking a nerve, so I'm glad there's some pain. Question number 5. How'd we do? Not bad, 64% correct. So a couple ways you can do this. this is where we get into the business of, I tend to call them mixtures, which I think is kind of a sloppy phrase for them. Weighted averages, if you prefer. So what's going on here? All the students either scored 800 or 500. I like to draw this out, make a little kind of number liney looking thing, and say we got a bunch of students who scored 500, we got a bunch of students who scored 800, and we know that the average of this whole group is 560. Now conceptually here, imagine this is in the middle for a second. So imagine that this is 650. And if I'm trying to say, let's call these, I don't know, let's call this group A and group B. What is this telling us? Is this telling us that there are more people in group A or more people in group B? Just think about that logic for a second. If you're quick on the draw in the chat, fantastic. If I tell you that group A, everyone scores a 500, group B, everybody scores an 800, the average is a 650, what do we know? It's got to be equal amount parts of both, right? 50% of the group has to be group A, 50% has to be group B. Another way to think about that is you can kind of take this little setup. And I'm going to get rid of the question for a second. We'll bring it back in a minute. You can kind of look at this little setup and go, well, wait a minute. What's going to define the proportions of these two things is going to be that distance from the average to the two endpoints. So here we have 150. Here we have another 150. One way to think about this is you could say, well, the ratio is 150 to 150, or 1 to 1 must be 50-50, right? Makes sense. Now, same logic is going to apply if we offset this a little bit. So if this is 560, got 60 here, I got 240 here, brain's starting to go, that subtraction's hard. 3 easy little steps for doing these, just to make sure you don't make a mistake on these kind of weighted average problems. And this is great. I'm getting some nice comments in here that people struggle a bit with this. So first step, I want you to think about what's there more of when you have these situations where it's a weighted average and you're being asked to kind of get to the proportion. I know in this case, I got more A for sure. Really easy step, nothing hard there, but I want to make sure you anchor yourself in that because it's really easy to get it flipped around later. And then I'm going to subtract to get the ratio. So in this case, I know that the ratio of A to B is 240 to 60. And I can reduce that to, oh wow, brain, 4 to 1. Please stop me, guys, if I make mistakes. So 4 to 1 is your ratio. Step 3, carefully combine. So combine 1 and 2. All I mean by that is just watch your back. Make sure you don't flip this around. Happens all the time. This is the single most common mistake I see from people who know a technique like this and are comfortable, but then they still flip this around. So is that A to B or is that B to A? I want this looking at you now. I want that on your page just to make sure you don't make that error. Again, theme of the day, let's stop you from making those errors that can kill your score. So damaging. It's one of those things about the GMAT that I find really frustrating. Just part of the adaptive model, you miss easy questions, it's going to start giving you more easy questions, and it's really, really hard to recover. Simulation studies that academic psychometricians have done, 2 dumb mistakes early in your test, and boy, it is hard to come up from that, almost impossible. Certainly on average, almost never happens. So I want to guard against that. Again, those things we see on the forum all the time. Hey, my score's lower than I expected to be. My mock exams were this. My real exam was 6 points lower on Quant. What happened? Careless errors. The question is why. So everything we do here, spend the extra time writing this down. You see a question like this, just to make sure this is looking in the eye. You're not going to make the mistake. You know this is the ratio of A to B. Okay, so once we know that, put the question back up on the screen. If I can find the button, there we go. Hey, we know the ratio is 4 to 1. We know there's 90 students. And we're out of here in a big old hurry. So 1/5 of these, what are we looking for? The high scorers, the group B, the way I labeled them. So we know that 1/5 of the total are the high scores. So 1/5 times, I think it's 90. Is that correct? Yep. And that's it. We're done. 18. And your answer is B here. Okay. A little tougher than I thought for you guys. We might do one more of these before we finish up the hour. Got about half an hour left here. Okay, let's do a couple of these min-max problems. We'll see how the time's going. Next one. Again, it just means we struck a nerve, means we got stuff to learn. It's a good thing. 5 different positive integers, mean is x. I'm sorry, I just misspoke, I think. I just said 5 different positive integers. It's 5 different positive temperatures. And it's interesting, I think I saw somebody in the chat call them integers as well. It's temperatures. Could be integers, could not be, right? These could be decimals. I don't think it says anything in the question that indicates that. 5 different ones. Mean is x, so what do I know? Well, I know the sum has to be 5x for all 5 of them. If I want the sum for the 3 biggest, well, if they were all equal, it'd all be x, right? And again, this is not possible. But it's got to be bigger than this, right? Because if they're different, then it can't be the case that these are all x. They have to be bigger than that on average. So whatever this average of sum of the 3 greatest, so I'll call it sum, put a little subscript 3 in there. That's got to be bigger than 3x. How much bigger? Not much, right? So if you look back at the language in the question, doesn't say anything about integers, doesn't say anything about how different they are. Maybe it's a tiny, tiny fraction of a degree. That's totally fine. So I know it's bigger than 3x, could be infinitesimally. Oh, that's a hard word to say at this hour. Just a tiny bit bigger than 3x. And we also know it can't be any bigger than 5x because the sum of all these guys, again, it's positive, can't be bigger than 5x. So here's what I know. Can it be barely smaller than 5x? Sure, these temperatures could be, I can erase the x's now. These first 2 temperatures, the lowest 2, could be just barely positive. It could be a fraction of a degree or something, that's fine. But we know that the sum of those 3 has to be somewhere between 3x and 5x. And now we're done. Can't be 3, that's too small, that's not even 2. Can't be this guy, can't be this guy. Your answer is 2. And that would be answer choice B. Okay, again, non-technical stuff. There's nothing here where it's like, hey, go review your stats book. Very, very, very little. No reviewing of the stats book needed here. It's just making sure that you're kind of thinking logically. And every question is just a little bit different on these. That's really all it is. And we can put a ton of these different ones together that kind of have this business of what do I maximize, what do I minimize, yeah, it's just following that logic, getting some practice on them. We're going to do 20 minutes left here. We're going to do one more weighted average problem, and then I want to do a couple standard deviation ones. Try to get into conceptual stuff. I think these 2 are from Binge, if I'm not mistaken. All right, come on back. Live group's doing pretty well with this, it seems. Also not seeing a ton of responses, which means maybe the silent majority is having a hard time. So this is really just kind of a conceptual data sufficiency version of what we had as I think it was the 5th question in the quiz, that weighted average. Sometimes I call them mixtures, sometimes I call them weighted averages. Weighted averages is arguably a more accurate term here. So I can kind of lay this out in exactly the same way and say, okay, we got females. Average for the females is, find a different color pen, whatever. My black pen go, there it is. So for the females, 12.5% increase. For the men, 23% increase. Now, as long as I know, all I really need here, as long as I know what percentage of the total, that's going to tell me the percentage of the 2 groups that we're mixing together. That's really all it is. First statement tells me absolutely nothing. 92% of the men had increased blood pressure. Absolutely irrelevant. We know that the average increase was 23%. So sure, maybe for some people, it went down, doesn't really matter. So that's not sufficient. And statement 2, overall average increase for the whole group is 19%. Going to be, I don't know, exaggerating a little bit, but 19%. No real need to calculate it here. It's data sufficiency. So this is 4. This is 4.5. Again, no real reason to go through it, but for whatever it's worth, you're going to have, if my math is right, that is not right. That's 6.5. Well, now we're number 17. So your ratio of men and women is going to be 8 to 13 fine, doesn't matter, you don't need to calculate it. But that's going to be enough to get you that proportion that's female right there. And again, yes, had a really good question there. Sorry, the answer is B. You do have to assume two genders here. Probably should have been specific about that. You know, we're leaving the non-binary out of this one, as is often the habit on the GMAT. Okay. I think we got time for two more. Standard deviation. Okay. I've got two here. Correct me if I'm wrong, Buñuel, I think you're watching. I'm not exactly sure. I think the last one might have been yours. Let's see. Let's come on back. This is a really good question. And yeah, not sure if I saw your answer in there, Buñuel. I think this was one of yours, but yeah, let me have that wrong. So some interesting misconceptions here. This is a little bit of a cousin to kind of that one we were doing with like the normal distribution, where it's like, yeah, if you've taken some stats, you know, recently enough that you remember it, you're gonna have a much better shot at this. A little bit knowledge based, but there's a layer of reasoning that I think I'm seeing some challenges on here. So is the standard deviation of these things greater than zero? We don't need you to understand standard deviation on a super technical level. No reason to memorize any of the formulas or anything like that. Real pain in the butt to calculate it directly. If I gave you 6 numbers and say calculate the standard deviation, it sucks. It's terrible to do by hand, depending on what the numbers are. But standard deviation is always going to be positive unless it's 0. So I was talking about pushing the question, one of those good hygiene habits to get into on data sufficiency. You know, honestly, I could rewrite this as sort of the inverse of it if I wanted to. I want to know, is the standard deviation of these numbers equal to 0? Because that's the only other possibility. If I can answer one of these questions, I can answer the other one, right? Because it can't be negative. Either it's positive or it's 0. When is the standard deviation going to be 0? When is that going to happen? It's only going to happen if all the numbers are the same. There's no deviation. So what is standard deviation? It's a measure of your spread. How spread out are your numbers? How spread out is your data set? If there's no spread at all, all the same number, there is no deviation. Your standard deviation would be 0. The more spread out it is, the bigger the standard deviation, obviously. So I could rewrite this again and say, well, standard deviation equal to 0. That's the same thing as saying, is x equal to y equal to z? So again, once you get a little bit of thinking leading off, now this is pretty easy, hopefully. If we're saying that the average of x, y, and z, so x plus y plus z divided by 3 less than x, only going to be possible if these are not the same number. Can't all be the same number. So this is telling us that the standard deviation is not 0. It's got to be positive then. So AD, so BC, you're out. A is sufficient because we're saying can't be the same if this is the case. If these are all the same number, then this is going to be equal, not less than. Similar idea on statement 2, median of x, y, and z is greater than z. X doesn't really matter. So if there's any variance here between the numbers, there's got to be a positive standard deviation. Unless they're all the same number, you're going to have a positive standard deviation. So we know here the numbers aren't the same because the median would be z if they're all the same. Median would be equal to x, would be equal to y, would be equal to z if they were all the same number. Not the case here. So your answer is D. All right. One more conceptual standard deviation, one pretty tough. I think it's pretty tough. Let's see what happens. Look, hard question from Buñuel here. Very conceptual, very difficult. This is beyond what most of you need. This is a fun challenge question. If you're going for that kind of 50-51, you enjoy stats, really good one for you. If you really want to go down the road of kind of doing, you know, stats on an academic level, fantastic. But this guy's tough. Kind of the underlying concept, a couple underlying concepts here, but one of them is what happens to a set as you kind of, you know, start, well, there's a lot going on here. I'm going to start with statement 1. So we know that the sets have more than one element each. We want to know the ratio of the two standard deviations. X, well, it's multiples of 5. And again, it's not to say that there's anything magical about 5, but just to kind of start to see what's happening here. There's a temptation here. I'm seeing a lot of answers that are A that say that one of these is going to have a bigger standard deviation than the other. Well, what if I only have 2 elements in X? Now think about what happens as I add more elements to X. Does the standard deviation change? Yeah, we're talking about spread, distance from the mean, standard deviation, average distance from the mean conceptually. And we're running out of time, so I apologize. I'm going to go through this pretty quickly and probably leave a few of you not so happy with the explanation. But multiples of 5, the temptation is to say standard deviation is 5. Oh, no, 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 no. I make this more spread out the more elements I put in there. This has a bigger standard deviation than if it's just 2. This is getting more and more spread out. We're getting more distance from the mean as I add more terms. So the number of terms matters here. Absolutely. So it could be the case that even though these are more like individually more spread out from each other, what if, so the temptation is to say A because there's more space between the numbers in set X and in set Y. That's a temptation. But what if there's only 2 elements in X, but Y goes on forever all the way up to 3,000? I have this massive spread. So conceptually, just looking at it intuitively, that's why A is not sufficient. Is that doesn't, so it's not that it doesn't matter, but these can be, these are less spread out from term to term. But if you have more of them, that standard deviation is going to be bigger. So AB is out. Statement number 2, number of elements is equal. Obviously by itself, that's not going to do anything for you. And now we're down to C and E. That's fantastic. And now this gets really, really, really tricky, I think. And again, I'm bumping up at the top of the hour here. So I'm going to wrap this up pretty quickly. If I'm not mistaken, Buñuel, please yell at me in the chat if I'm barking up the wrong tree. Again, we put this all together on pretty short notice. Some of Buñuel's questions I grabbed, threw them in here, didn't get a chance to really look at them in detail. So I might be wrong here, and if I am, happy to admit it. But if these are all the same number of terms, it doesn't really matter where you start and end. So this could be 6, 9, 12. That's the exact same standard deviation as 9, 12, 15. Same spacing between the numbers, same standard deviation. So it doesn't really matter where you start and end. We can kind of pull that out of it and just say, well, number of elements are equal. That spread, so if we have, I'll draw it up for a moment, is, let's say there's 4 numbers in each. So nice and symmetrical here. Again, it doesn't really matter where you start and where you end as long as it's the same number of terms. And we have a consistent ratio of the spacing between terms. It's actually going to be the case that you have a consistent ratio of those standard deviations. And your answer here is going to be C. And unfortunately, we've got a schedule to keep. So I'm going to mic drop there. Let you guys spend a little bit of time with it on the forum. Feel free to tag me in that thread. I mean, Buñuel is going to answer the questions better than I am anyway. But since I brought this up in this lesson, feel free to go to that thread, Abhijit or Buñuel or Nikhil, whoever's listening. Let's try to make sure we get this particular link into the description for the video too, please. And that way, if you want to go spend a little bit of time on this, again, way beyond for most of you guys. If you're going for a 47, 48, you don't need this. But really, really fun thing. And if you're a little bit of a stats geek, I think it's kind of fun to think about that and why it is that when you kind of scale up the entire ratio, you scale up the spacing, that means you're evenly scaling up the entire ratio. Fun explanation there. Again, if you want me to weigh in on the thread, just tag me in a few days once I get a few nights sleep. All right. Thank you so much for joining us, everybody. Stats is in the books. That was, where were we? That was hour number 17. Thank you, everybody, for watching once again.